Okay, today we want to look at parallelogram proofs, and most of these, if not all of these on today's worksheet, will be on a coordinate grid. Just as a reminder, these are properties of a parallelogram. Both two pairs of parallel sides, two pairs of congruent opposite sides, and again, these are opposite sides, right? Opposite sides are congruent, opposite sides are congruent, like in a kite, consecutive sides will be congruent. Both pairs of opposite angles are congruent. So these angles and these angles. And then consecutive angles are supplementary, meaning all consecutive angles, not just one pair or two pair. So these, and those, meaning every single pair of consecutive angles, meaning angles in a row, are supplementary, which means they add up to 180. And then the diagonals, which are not seen in this picture, they bisect each other. They do not bisect the angle. They do bisect each other, which means they intersect at each other's midpoints. Again, that's how you'd show that. Again, these are properties. Yesterday we literally looked at the area, which was pretty easy, which was just base times height. This is the base, and this is the height. You could flip it around and make C the base, and then this distance, right? The perpendicular distance between the two bases is the height. The perimeter, of course, is just the distance around. Today's focus is really going to be about proving something is a parallelogram. So we're going to take a quadrilateral, which is a four-sided figure, four-sided polygon, and then we're going to try to prove it's a parallelogram. These are all the different ways you can prove it. Okay, again, this is the definition. This is probably the easiest thing, is to show me that both pairs of opposite sides are parallel. Or you could show me that both pairs of opposite sides are congruent. Okay, these are probably the two keys. So how do you show opposite sides are parallel? Well, how do you show two lines are parallel? Well, you show that they're the same slope. How do you show that opposite sides are congruent? Well, you show me they're the same length. These two are really the key. Again, we show things are parallel by looking at slopes. We show things, meaning side lengths, are congruent by looking at the length of the side length. Both pairs of opposite angles are congruent. That's a little more difficult to prove sometimes in a coordinate, because finding angles is more difficult. An interior angle is supplement to both of its consecutive angles, meaning if this guy's like 70, if you show me that's 110 and that's 110, then that's enough. Because this is 70 and this is 110 and this is 110. Well, they'll all have to add up to 360 because it's a quadrilateral. So we also know that that has to be 70, and then we have 70, 110, 70, 110, 70, 110, and 70 and 110 degrees. And then we know this is true. If the diagonals bisect each other, then we know this is true. How would we know the diagonals bisect each other? Well, we'd have to show that the intersection of the diagonals is actually their midpoints. Okay, we could do that. Or we could show that one particular pair of sides is parallel and congruent. Again, we show parallel by showing the same slope. We show congruent by finding the distance, which is using like the Pythagorean theorem. Okay, so let's look at this again. Okay, so if this was our sheet, and if we had a coordinate grid, and I looked at, I don't know, I gave you a point here, and a point here, and a point here, and a point here, and you were interested in showing me whether or not you thought this was a parallelogram. Again, a slope is rise over run, which is, like a y2 minus y1, or x2 minus x1. On a graph, the slope is usually pretty easy, because if we looked at the slope of this line, I would just go like this and like this. Okay, and let's say this is up 5 and over 2. I can come over here, and I could do the same thing either here, here, or here, here, it doesn't matter. And I can show that this line is also up 5 and over 2. Right? Both of them, in this case, have a slope of 5 halves, which means that that guy is parallel to that guy. Okay, so remember, slope is going to be this 5 halves. rise over run. Again, I don't know what these coordinates are, but it's 2 over and 5 up. It's 5 up and 2 over, which is the same thing. Okay? What we also can do then is find the length of these guys. Again, this is all about slope. This is showing me that both of these have a slope of 5/2. That's showing me that these things are parallel. Now, if I wanted to find their distance, I would call that like some letter C, and then I would say, okay, the Pythagorean theorem is true, because that's a right angle. So 5 squared plus 2 squared equals C squared. 25 plus 4 equals C squared. And so C equals the square root of 29. But over here, I could do the same thing. This is some D, and I would get 2 squared plus 5 squared equals D squared. And of course, we would get D equals the square root of 29. And then this is showing me that C is congruent to D. And so now what I've shown you is that last thing. I just showed you that this and this are both congruent, meaning the same length, and parallel, same slope. Thus, this has to be a trapezoid. Again, that was one of the 6 ways, I can do it. I just did number 6. I showed you that one pair of opposite sides is both parallel and congruent. Okay? We could do, like I said, if you had an example on a coordinate. You could also just find this slope, this slope, this slope, and this slope. And you could show me that those 2 slopes were the same. And you could show me that these slopes were the same. And then that's enough to prove it's a parallelogram. So you're going to have different options today. I think most of the problems are actually going to tell you what method to use. But on a coordinate grid, you have the ability, most of the time, on a coordinate grid, you have the ability to find slope, and you have the ability to find the length of a line segment. And so what you can do is you can show me the 2 line segments are congruent, and you can show me that 2 line segments are parallel, and those are going to be the key pieces in doing a coordinate proof in terms of determining whether or not you think a quadrilateral is a parallelogram. Again, here are the 6, and I think I've even highlighted those in the worksheet today. Showing me these things is proving to me that a quadrilateral is a parallelogram. Okay? Good luck in your assignment, and let me know if you need any help.